Let's talk a little bit about how the WAN's built and transitioning from traditional network infrastructure to SD WAN and building that modernized infrastructure to support it. So as we dive into MPLS, when MPLS was introduced really 2 decades ago, and customers have built upon it over the last 20 to 15 years, it was really a good fit for growth of private networks, especially given kind of that centralized enterprise architecture where customers are accessing resources from a centralized location. Well, as users and applications that become more distributed, and we see in the advent of SD-WAN, that traditional network infrastructure has become more of a constraint on the network. So some of the biggest pieces of that is if I do want to add additional branch sites, if I want to add additional service providers, typically it's going to be 30 to 60 days for me to add a node on my MPLS network. Also, while the carriers that we work with to build out these SD-WAN or these MPLS networks have a vast reach and on-net locations, typically they're not going to be on net to every location that the enterprise ultimately wants to reach. So they're going to have to procure type 2 services to integrate into this MPLS platform, which is going to add additional time, additional complexity, and additional costs. So no bandwidth optimization, it's all private network connectivity. Just as I have issues in adding additional branch sites with the extended timeframes, I'm also going to have issues in adding cloud connectivity in the regions where I want to access those applications. So to add just a single cloud provider, I'm going to be running into that 30-day window. If I want to add multiple clouds, well, that's just a whole nother complexity of adding that into MPLS. Also, if you look at this traditional network architecture, typically customers are backhauling traffic into the data center where they have their security stack or setting their security preferences to route back out to the internet to access those SaaS applications, or routing into private environments within the cloud providers. So backhauling traffic with distributed users and applications that are moving to the cloud, not seeing the great application performance. So as we talk about strategies and transitioning from MPLS into SD-WAN and modernizing that network, some of the challenges that customers review when they think about eliminating MPLS. So in a lot of cases, customers that we're working with that have deployed SD-WAN, they still kept some or all of their MPLS network because they like the predictability and performance across longer spans of the network. Well, when we look at modernizing the infrastructure and modernizing the connectivity, now via network as a service platform, there are strategies that I can utilize that take both the best of the internet and predictable paths across an SLA-backed backbone. So one of those terms that we hear quite a bit is building a middle mile type of solution. That really means I'm taking a short hop across the internet to get on an SLA-backed backbone. So the majority of that path is going to be on a backbone that I get predictable latency and performance. So building out connections across my backbone that mimic or look very similar to MPLS, but not having to deal with that MPLS, the limitations of traditional network of MPLS. Looking at expanding that out just a little bit further, maybe I have operations that I want to connect in multiple regions. So I have a business in Sydney, Australia. I want to connect those branch locations into my network. I can deploy an MVE. I can utilize that short hop across the internet, have that predictable path to another region. Maybe this is in Singapore, or Hong Kong, or Tokyo, but I can deploy an MVE in that region. And then I can utilize another short hop across the internet. So I'm getting that predictable performance across the backbone. So with that MVE solution in Megaport's network as a global network as a service backbone that we've built out, it enables you the ability to build these private connections to replace your traditional MPLS network via global SLA-backed backbone, having those short hops across the internet. So now you're also eliminating the cost of building out private connections to each one of these locations and utilizing that DIA access. You also have the flexibility to increase or decrease this bandwidth across the backbone, as you require. So you're not locked into any bandwidth requirements that you would from a traditional infrastructure. So as we're building on top of the backbone, let's talk about that, adding that cloud connectivity. So backhauling cloud traffic back into the data center, not optimal for those applications. And we know that adding regional cloud connectivity to a traditional network, also not an optimal way of doing business. Additional costs, additional time. So now, not only can you build that backbone, but you can add private connectivity. So if you want to access your VPCs, or maybe you have SaaS solution or SaaS applications with Salesforce, all of that can be built and localized within the region. So now the branch traffic, as it comes into the virtual edge, I can access those applications from the SaaS side of the business. I can also access my VPCs. So if I want to access my VPCs in AWS, I can do that. If I want to add additional cloud providers, I can do that as well. Now, as we build upon that regional model, same type of approach, right? In the region where I need those cloud applications, I'm keeping those routing decisions local. I still have the backbone connectivity. So if I need to route from my branch to a data center in another region, I'm going to be relying on that backbone for that predictable performance, but I can also match those cloud applications in the other region. So again, a lot of those same principles: on demand, private connectivity built to the cloud. So whether you need AWS or GCP, those can be added. Now, the other benefit here is at Megaport, we've got over 230 cloud on-ramps. So those are typically going to sit right at the edge of the MVE. So you're going to have very short hops to get on that cloud provider network and access those regions. You're also eliminating the expensive cost of adding connectivity into the cloud, while also, again, not having to build out those private connections to your branch locations. And then, adding those additional cloud providers as needed. One of the great things too, when we talk about kind of a seamless transition into SD WAN, so if we look at just the basic path of a branch into the data center, we can deploy MVE in parallel. To where I can create that path from the branch into the data center. I can build all of this on demand. I can physically connect in the data center as well. So I can build a path that's going to be over a private SLA backed backbone, have that short internet hop. So there's a couple different ways that you can look at this. One, it's an easy way for me to build a transition strategy off of MPLS. It also gives me the ability to still potentially maintain portions of my MPLS network if I have a specific route that I want to keep on a private connection model, or maybe a private point-to-point. I can keep that, and I can also then build out a similar path, a secondary path over a virtual platform. We also have customers that maybe they have locations that they want to keep on that traditional network and manage MPLS separately, and then build out an SD-WAN backbone via the virtual edge with Megaport. So lastly, looking at existing SD-WAN deployments. So we've talked about some of the limitations of MPLS, but now as we build the internet underlay on top, start looking at how our branches, so we've got a combination here of internet and MPLS as the underlay for our SD-WAN overlay. Now, as we look at how our branches are going to access those clouds, you're going to have a direct hop from the internet to those cloud applications. So with that, you're going to be relying on the internet end to end. You're also going to be most likely deploying SD-WAN deployments within each one of those cloud providers. So as you start to build out into additional clouds, you're going to be building out additional infrastructure within those cloud providers. You're also going to have to manage multiple IPsec tunnels to each endpoint that's connected on the network. So depending on how you built out that topology and the resources that they want to access, you're going to be building out multiple VPN tunnels across the internet spans. You're also going to have to manage that existing MPLS routing on the underlay as well. So if we look at kind of the Megaport solution, to me, this is combining really the best of both worlds. You get predictable performance and being able to build out a private backbone globally between the regions where you're doing business. You also have the ability to just utilize a short hop over the internet, build out private connections to the cloud. So you're getting the private connectivity into the cloud that many enterprises prefer. You're also getting the ability to reduce some of your cloud charges from a data transfer fee. And we'll talk more specifically about some of these use cases as Mark goes more in depth here in a minute. The other piece is you're now able to simplify the routing, so you can keep all of the routing local and access the resources that are built on each one of these routing hubs, but you can also then connect directly into your data centers. So Megaport's got those 700 able data centers. You can connect to those endpoints as well. It also gives you ability to have a strategy around adding remote users. So if we look at kind of some of those SASE applications of where I'm building SASE POPs, network as a service and security as a service, I can now build that on top of Megaport Compute. So if we think about kind of how customers are moving from heavy branch where they're racking and stacking network equipment, maybe they have a firewall, now they can host the network and security as a service on top of that Megaport infrastructure and take advantage of the new security technologies and network services that can be deployed on a compute resource. So if we look at adding remote users, it also gives you a strategy to bring that edge of your network closer to those remote users, where you can utilize some of those zero trust network access services that you'd see from those SASE applications.